Tomorrow morning, you might open the refrigerator, grab a carton of milk, and pour it over your cereal, or add a splash to your coffee. The entire thing takes 5 seconds, and you probably won't think about it at all. But the strange part isn't that you drink milk, it's that your adult body may be able to digest it. For most of human history, producing large amounts of lactase throughout adulthood was not the normal human condition. In most mammals, including most humans historically, lactase production declines after weaning. That's not a defect. It's the ordinary shutdown at the end of infancy, repeated across most of the mammal world. Once you're no longer nursing, the enzyme that breaks down milk sugar quietly winds down because there's no more milk expected to come. Humans didn't fully follow that pattern. At some point, people started drinking the milk of other animals, animals they hadn't nursed from, animals whose milk their adult bodies weren't necessarily built to handle easily. And for thousands of years afterward, biology hadn't caught up to what people were already doing. So here's the real question. When did people first start drinking milk that wasn't meant for them? And what did that decision actually change about how they lived? To answer that, you have to start with the animals themselves. Across the Fertile Crescent, a broad arc of land running through parts of modern Turkey, the Levant, Iraq, Syria, and Iran, people began domesticating goats and sheep roughly 10 to 11,000 years ago. Cattle domestication followed within a broadly similar window. This wasn't one event in one place. It unfolded gradually across communities shifting from following wild herds to keeping and managing their own animals. Early herding communities used animals for meat and other resources. Dairying introduced a fundamentally different advantage. A living lactating animal could provide food repeatedly without being slaughtered. Killing an animal gives you one supply of food, once. A living lactating animal gives you something that renews itself for as long as it's kept alive, fed, protected, and allowed to breed again. That's not a small difference. It changes what a herd actually represents to the people keeping it. A slaughtered animal is a single transaction. A milked one is closer to an ongoing relationship, one that has to be maintained rather than simply spent. Maintaining that relationship would have meant a very different set of daily demands than raising animals for meat alone. A female only produces milk after giving birth, so herders would have needed to think carefully about breeding, about which females to keep for how long, about timing offspring so that milk was available across as much of the year as possible. Newborn calves, lambs, and kids still needed some of that milk themselves, so any human use of it likely meant a kind of negotiation, taking a portion without taking so much that the young animal suffered. None of this required writing, mathematics, or formal record keeping, but it did require the kind of close, sustained observation that only comes from living alongside the same animals for years. Watching the same mothers give birth season after season, learning which ones produced more, and for longer. This is also where the herd stops being a single resource and starts being infrastructure, something built and sustained over time rather than something simply harvested. Protecting animals from predators, moving them to find grazing, keeping them healthy through illness and hard seasons, all of it now had an additional purpose beyond eventually providing meat. The herd itself had become a kind of standing investment, and milk was the return on that investment, collected again and again rather than once. We cannot know who first tried drinking another animal's milk, or what exactly they were thinking when they did. There's no name attached to this. No single documented person, no dramatic accident preserved in the record. What we can reasonably picture is something slower and less cinematic. People already living closely with their herds, watching young animals nurse, noticing how much milk a female produced and for how long. Perhaps someone tried collecting a little of it. Perhaps that happened independently, many times, in many households, long before anyone thought to keep containers specifically for it. One possibility is that milk use began almost as an extension of everyday animal care, not as a separate invention at all. The archaeological evidence cannot show us the exact moment this happened, and it would be a mistake to invent one. What the evidence can show us is that once dairying does become archaeologically visible, it's already happening in more than one place, among more than one animal. By approximately 6,600 to 6,400 BCE, communities across Anatolia, Upper Mesopotamia, and the Iranian Zagros were exploiting and processing milk from cattle, sheep, and goats. These are among the earliest secure direct traces currently known, not proof of a single point of origin. No one settlement, no one vessel, no one population gets to claim the title of first. Researchers describe Anatolia and the Zagros as independent but approximately synchronous trajectories of early dairy exploitation, arrived at separately, in different landscapes, with different animals. In Anatolia, cattle appear to have been central to the practice. In the Zagros, sheep and goats seem to have carried more of that role. That difference matters. It suggests dairying wasn't a single technique invented once and carried outward, but something closer to a shared pressure meeting different animals and different terrain in different places, and arriving at broadly the same solution. That gap between the first domestication of these animals and the first secure evidence of dairying spans roughly 2,000 years. That doesn't mean people waited 2,000 years to think of it. Earlier dairying may simply have left less behind to find, particularly before pottery became common enough to trap and preserve the fats inside it. A community without pottery could still have been milking animals. They would just have had a few ways of leaving anything a modern chemist could detect thousands of years later. Once dairying was underway, it reorganized daily life around the herd in ways that killing an animal for meat never had. Keeping the animals alive meant protecting them from predators and disease, managing which females were bred and when, and timing collection around lactation itself. Someone had to gather the milk, hold it in some kind of container, and figure out what to do with it before it spoiled, because unlike grain, fresh milk doesn't wait. We don't know the exact rhythms different communities settled into, and it would be wrong to claim a fixed schedule or a single method every household followed. But the underlying shift is clear enough. A herd could now be a continuing food source, not only a stockpile of future meat. That perishability created an obvious problem. Fresh milk spoils quickly without refrigeration, and on top of that, most adults at the time likely still lost much of their ability to break down the sugar in it after childhood. Put those two problems together, and dairying only makes sense as a long-term practice if people found ways around them. Part of the answer may have been simple tolerance. Reduced lactase production doesn't mean every person becomes ill from any contact with milk. Some adults could likely manage a modest amount without much trouble. But another part of the answer was almost certainly processing. Turning milk into cheese separates out most of the liquid whey, and lactose dissolves mainly into that whey rather than staying in the solid curd. So a block of cheese can end up carrying only a fraction of the sugar in the milk it came from. Fermenting milk works differently, but toward a similar result, since the microorganisms doing the fermenting feed on the lactose itself as part of their own process. Processing milk into cheese and fermented products would have reduced its lactose content this way, whether or not early communities understood the biological reason behind why it helped. It also would have made part of the supply last longer and travel further, turning a fast-spoiling liquid into something that could be stored or carried, useful for households facing lean seasons or needing food that could survive a journey. Evidence interpreted as 6th millennium BCE cheesemaking in parts of Europe shows some communities were already transforming milk this way, though it isn't proof that every dairying community did the same thing, or that fermentation was deliberately invented to solve a digestive problem rather than discovered as a useful side effect of simply trying to preserve food. Some fresh milk may also have been consumed, but the evidence generally cannot distinguish fresh milk from processed dairy. Piece by piece, this turned dairying into something closer to a small ecosystem of its own tasks, breeding decisions made months in advance, daily attention to which animals were lactating, containers built or chosen specifically to hold a liquid that didn't keep, and some portion of each day's yield transformed into something more durable. None of this shows up as a single dramatic invention in the archaeological record. It shows up as a pattern, spread across sites and centuries, of people quietly building an entire practice around an animal that used to matter mainly for its meat. We can trace some of this directly to individual people, not just to pots. Researchers identified dairy fats in ancient pottery by comparing carbon isotope signatures preserved in the fat molecules against known reference ranges, which helps distinguish milk fat from meat fat. Pinning down whether that milk came specifically from cattle, sheep, or goats usually takes additional protein or archaeological evidence on top of that. Milk proteins preserved in human dental calculus, The hardened plaque on ancient teeth go a step further, showing that a specific person consumed an animal-derived dairy product. In Britain, researchers examined dental calculus from Neolithic individuals dating to roughly 3,800 to 3090 BCE. At one site, Banbury Lane, milk protein was detected in one person's dental calculus. Separately, none of the 3 people genetically analyzed from that same site carried the derived lactase persistence allele. Together, these findings offer site-level evidence of dairy consumption in a population where the derived lactase persistence allele was not detected in the small genetic sample, though the protein and genetic results can't be assigned to the same individual. And 3 people are far too small a sample to prove the allele was absent across the whole community. Still, it's a striking snapshot. People consuming dairy in a place where the biological tool for easy adult digestion may have been rare or missing among at least some of them. That's the real historical surprise sitting at the center of this story. Ancient communities were herding, milking, and processing dairy for thousands of years before lactase persistence became common in some later dairying populations. Culture moved first. Biology, in the places where it moved at all, followed much, much later. Ancient DNA shows just how long the delay really was. At Tollensee, a Bronze Age battlefield site in Germany, dating to roughly 3,200 years ago, researchers analyzed 14 individuals. Among them, one carried the principal European lactase persistence allele, giving an estimated frequency of approximately 7.1% in that sampled population, not a claim about every person at Tollensee or across Bronze Age Europe generally. By the time of that battle, dairying had existed in Europe for more than 4,000 years. Measured from the earliest secure Southwest Asian evidence, the gap exceeded 5 millennia. Whatever advantage the allele eventually offered, it clearly hadn't reshaped the population carrying it yet. During the following 3 millennia, lactase persistence rose sharply across parts of Central and Northern Europe, traceable through later ancient DNA samples, though it never became universal across the continent, let alone across humanity. And this didn't happen only once. Lactase persistence evolved independently multiple times. Researchers have identified several African variants that differ from the principal European one, and from each other, arising separately in different populations across Africa and the Middle East. Different groups herding different animals in different environments arrived at a similar biological outcome through entirely separate genetic paths. Why the advantage was strong enough to spread at all remains genuinely debated. Milk's caloric density is one obvious candidate, but a major study examining dairying, disease, and lactase persistence across Europe found that how much milk a population historically used didn't predict the strength of genetic selection as well as expected, and pointed instead toward famine and infectious disease. In hard times, people who drank milk despite lacking the allele may have suffered worse illness and higher mortality than those who could tolerate it easily, which, if correct, means the allele spread not because milk made healthy people healthier, but because it spared some people from a worse outcome during the worst moments. This remains one possibility among others, not a settled conclusion, and it would be a mistake to compress the story down to people drank milk, so the allele spread. Evolution eventually met some populations there, but not humanity as a whole. For many adults, lactase production still declines after childhood, preserving the older human pattern. So tomorrow morning, when you open the refrigerator and pour milk over your cereal, remember, the strange part is not that some adults struggle to digest it. The strange part is that any adult can keep digesting its lactose with ease at all.